Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have started a series where we are discussing the top 30 questions from all the important chapters. In today's video, we'll be discussing top 30 questions from the chapter Thermodynamics. So it is a low weightage topic for your KCET 2024, but there are certain, it is very easy scoring chapter because there are certain base formulas from where the questions are asked. So in today's video, we'll be discussing those questions, important questions which is asked from your KCET exam. So let us see the first question. Lattice enthalpy for NaCl is 788 kJ per mole and the hydration enthalpy is minus 784 kJ per mole. The enthalpy of the solution is. So this is question is from your Hess's law. Like what happens when you delta H of solution is equal to delta H lattice enthalpy plus delta H of hydration. Okay. So we can just, both the values are given, we need to know this equation here. So if I calculate here, delta H of lattice enthalpy is 788 and hydration enthalpy is minus 784. Okay. So the correct answer for this one will be the plus 4 kilojoule per mole. Right. So the correct answer for this question is option number B. Next. The work done when 2 moles of an ideal gas, 2 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liter at 300 Kelvin. R value is given to us. We have to calculate the work done here. So this is very, very important formula and one of the formula from where most of the questions are asked. So W is equal to minus 2.303 nRT. So let us first write down the formula nRT log of V2 by V1, right? So if I substitute the values, minus 2.303 into N is number of moles, that is 2, R is 0. You can take here since it is 0.083, and then we have temperature is given to you as 300 Kelvin log of 10 by 1. Okay. So now if we see here, this answer will come in the units of, so we need not take R in this unit, you can take it in the units of 8.314 because the options are in kilojoule, right? So 8.314. So the answer for this will get in joules, divided by 1000 will get in the terms of kilojoule. Okay. So the correct answer for this question will be option number C, that is 11.5 kilojoule per mole. Next. Bond enthalpies of A2, B2 and AB are in the ratio of 2:1:2. If the bond enthalpy of formation of AB is 100 kilojoule per mole, the bond enthalpy of B2 is. Okay, so first of all, A2 and B2 is reacting to give you AB, right? Whenever you write the reaction for enthalpy of formation, the product should always be 1 mole. Okay, this is very important. Whenever we write delta H of formation, the product should always be 1 mole. Okay. Why? Because the definition of enthalpy of formation is the energy released when 1 mole of a compound is formed from its elements in the native state. So we have to form A2 plus B2 is giving us AB. Okay. This has to be 1 mole. So we cannot make it 2AB, means we can make it, the calculation will be different. So we have to make it as 1 mole. So here I'll write half and I'll write half here so that the equation is balanced. Now, according to the equation, the bond enthalpy of A2, let it be 2x, okay. Bond enthalpy of B2 is x and bond enthalpy of AB is 2x, right. So now we can put it in the formula. Delta H of formation is bond enthalpy of reactants minus bond enthalpy of products. Right, bond enthalpy of reactants minus bond enthalpy of products. So now we can put the values here. So bond enthalpy of reactants is A2 and B2. A2 value is 2x. This coefficient also should be considered. So I'll write 1 by 2 of 2x plus 1 by 2 of x. Okay, this is bond enthalpy of reactants minus bond enthalpy of product is 2x AB. Right. So if we solve this equation, I'll get x plus x by 2 minus 2x. So if we solve this, we'll get 2x plus x minus 2x, that is x by 2. According to the question, the enthalpy of formation is given minus 100 kilojoule per mole. So I can write this one is minus 100 kilojoule per mole. That means x value will be 200 kilojoule per mole, right? So, and if you see, the bond enthalpy of B2 was x. So bond enthalpy of B2 will be x kilojoule per mole or 200 kilojoule per mole. So the correct answer for this question is option number C. Next, when the same quantity of heat is absorbed by a system at two different temperatures T1 and T2 such that T1 is greater than T2, the change in entropy of delta S1 and delta S2 respectively, then what is the relation? So if we know delta S is equal to Q by T, okay. According to the question, so this is one, delta S1 is equal to Q1 and delta S2 is equal to Q by T2, right? Same amount of heat is there, so Q is same for both the cases. Now according to the equation, I can say delta S is inversely proportional to temperature. So if T1 is greater than T2, if T1 is greater than T2, then delta S1 will be less than delta S2, right? Inversely proportional. So the change delta S1 will be less than delta S2. Correct answer for this question will be option number D. Next one. So this is option number D. Next question. The reaction in which delta H is greater than delta U. So for this we have the equation delta H is equal to delta U plus delta Ng RT. Now if we have delta H is greater than delta U, then delta Ng must be positive, right? So delta Ng, in which case it will be positive. For first equation, if you see delta Ng, how to calculate? The number of moles of products minus the number of moles of reactants. So for option number A, if we calculate delta Ng, this is 2 minus 2, right? So that is equal to 0. So in that case, delta H will be equal to delta U. Now if you check option number B, here delta Ng is, in the product side only 1 and in the reactant side 0. So 1 minus 0 is 1. So this can be the answer. Let us see option C, delta Ng, that is 2 minus 4, that is equal to minus 2. So this is negative. And for the last option, we will get delta Ng is equal to 1 minus 3, that is again minus 2. So the correct answer for this question will be option number B. Delta Ng should be positive. Next, a reaction has both delta H and delta S is negative, the rate of the reaction. So for this one, we have this equation delta G is equal to delta H minus T delta S. According to the question, both are negative, so we can write delta H plus T delta S because delta S is negative. Now if you see the equation like when the rate of the reaction will be faster if it is a spontaneous reaction. For spontaneous reaction, the temperature value should be less so that this term is less than this term and the overall answer comes out to be negative. So that means the answer can be the rate of the reaction increases with the decrease in temperature. Okay, so if we decrease the temperature, we can have the temperature when it decreases, we'll get the value lower, and then if you subtract it, we'll get delta G as negative. So the correct answer for this question is option number C. The next question. Bond energies of HH, Br and HBr are given to the value we have to calculate the delta H of the reaction. So again, bond energy delta H of reaction will be equal to bond enthalpies of reactants minus bond enthalpies of product. So we can substitute the values here. For H2 it is 433 plus for Br2 it is 364. So this is the enthalpies of reactants minus for product it is 2 HBr, so 2 times of 364. Okay. So if you solve this, the answer for this question will be option number minus 103 kilojoule. That is your option number D. So correct answer for this question is option number D. It's very simple addition subtraction calculation. Just check it once. Next, the correct statement regarding entropy. At absolute zero temperature, the entropy of a perfectly crystalline solid is 0. This is correct. This is your third law of thermodynamics. So the correct answer for this question is option number A. So this is direct statement based question. So you should know the definition of first law, second law and third law for thermodynamics. Next, in the reaction S plus 3 by 2, so we have two reaction here. S plus 3 by 2 gives SO3. Here the value is 2x, and another reaction is SO2 plus half O2 is SO3. This value is Y. Now heat of formation of SO2. So whenever such question comes, you have to arrange the given equation to form SO2. So from the given equation, if we reverse the second equation, then we'll get the value as SO3 gives SO2 plus half O2. Okay. And now if I want to write the reaction for formation of SO2, So according to the definition, formation of SO2 will be that reaction where 1 mole of SO2 is being formed from the elements in their native state. So S plus O2 will give us SO2. So our required equation is this one, and we have to arrange the given equations in this way. So now if I add this reaction, that is your first reaction, and this one second reaction, if I add, we will get here S, then SO3 will be cancelled. 3 by 2 and minus 1 by 2 will get O2 is giving you SO2, right? So when the reaction is reversed, the delta H value also gets the sign changes. So this one will become minus Y. So the addition will be 2x minus Y. So the correct answer for this question will be option number D. So such type of questions where Hess's law is used is important. So this topic from thermodynamics, that is thermochemistry, you can practice some numericals from this topic. Next, the ratio of heat liberated at 298 Kelvin from the combustion of 1 kg of coke and by burning of water gas obtained from the kg of coke is, okay. So we have this ratio. So when coke was burnt, the energy release, that is the energy of combustion, is given to you as 393.5 kilojoule, okay. And the combustion of water gas, so water gas is nothing but the combination of carbon monoxide and H2. So combustion of CO, we will get the value is 285, and combustion of H2, the value is also 285. So the question is very simple, the ratio of the energy released during the combustion of coke to that combustion of CO and H2. So the ratio will be 393.5 divided by the total energy released here, that is 285 plus 285. Okay. So if you solve this, the answer will be around 0.69 to the power is to 1. So the correct answer for this question is option number B. Okay, next. Conversion of oxygen into ozone is a non-spontaneous process at all temperature. Okay, this is very important one. Ozone is an unstable compound, so oxygen will not convert to ozone. It will be non-spontaneous at every temperature. Okay, correct answer for this question is option number A. Next, 2 moles of an ideal gas expanded isothermally and reversibly from 1 liter to 10 liter at 300 Kelvin. The enthalpy change for the reaction. So for this one, we have the second law, that is delta H is equal to delta U plus W. According to the question, this isothermal process, delta U will be 0. Okay, so delta U is a function of temperature. Since temperature is constant, delta U will be 0. So we can write delta H will be nothing but equal to the work done. Now since it is isothermal reversible process, work done formula is very important here, minus 2.303 nRT log of V2 by V1. Okay, so just substitute the values here, minus 2.303, N value is given to you as 2 moles, R value is 8.314, temperature is 300 Kelvin, and log of V2 by V1. So it is from 1 liter to 10 liter, so log 10 by 1, log 10 value is 1. So the solving, we will get the value as minus 11.4 kilojoule. Okay, so delta H value is nothing but the work done value. So work done value will be equal to minus 11.4 kilojoule. Delta H will also be equal to minus 11.4 kilojoule. So the correct answer for this question is option number B. Next, 2.1 gram of Fe combines with S evolving 3.77 kilojoule. The heat of formation of Fe is in kilojoule per mole. Okay, so according to the question, Fe combines with S to give FeS. Okay, here Fe weight is taken 2.1 gram. So when we take 2.1 gram of Fe, the energy that was released was 3.77 kilojoule. Now for 1 mole, how much it will be there? So that is, we can calculate 1 mole means it is 56 gram of Fe. So according to the question, 56 gram of Fe is burnt, then how much energy will be released? So we will have for 1 mole 3.77 by 2.1 into 56 will give you gram this much joule per mole. Okay. So if you solve this, the correct answer for this question will be option number C. Okay. So since this is energy is released, heat of formation will be negative, so the value will come in negative. Okay. So enthalpy of combustion and enthalpy of formation, okay, these two values are always negative because energy is released in the process. Next, given that C plus O2 gives CO2, delta H is minus A kilojoule, 2CO plus O2 gives 2CO2, delta H is minus B kilojoule per mole, the heat of formation of CO. So this is again a question from Hess's law. So we have to write the two equations given here. C plus O2 gives CO2, delta H value here is minus A, and then we have 2CO plus O2 gives 2CO2, delta H value here is minus B. Okay. Now the heat of formation of CO, so first you have to write the required equation. So according to the definition of heat of formation, 1 mole of CO should form from the elements in their native state. So if you want to form 1 mole of CO, we have to take carbon and half of O2, right? So now you have to arrange these equations to get this equation, and then the same operations you have to do on the enthalpy also. So we need first carbon, and CO should be on the right hand side, right? So we can reverse this second equation. So if I first reverse the second equation, I'll get 2CO2. So we can reverse the second equation. So I'll get 2CO2 gives 2CO plus O2. So now delta H value for this one will be plus B. Okay. Now if you see, we need to produce only 1 mole of CO. Here we have 2 mole of CO. So we can divide the whole equation with 2. So it is CO. Okay. So now if we divide this whole equation by 2, we'll get CO2 will give me CO plus half O2. Now when you have multiplied half to the whole equation, the delta H value should also be multiplied with half. So delta H value now will be equal to B plus 2. So now we have two equations. This is my first equation and this is our second equation. Add these two equations to get this equation. So if we add these two equations, you can see here carbon dioxide will be cancelled from both sides. We are left with C here and 1 O2 here and half O2 here. So we'll get half O2 here divided is equal to CO. So now if you see the equation, we'll have B by 2 minus A, that is equal to B minus 2A by 2. Okay, so the correct answer for this question is option number C. Let us see the next question. How much energy is released when 6 millimoles of octane is burnt in air? Given delta H for CO2, H2 and C8H8, so we can write down the values here for CO2, H2O and C8H18. For CO2 it is minus 490, for water it is 240 and for C8H18 it is 160. So we have to calculate the combustion reaction. Okay, for combustion the values will be negative. So first write down the equation of combustion. C8H18 plus O2 will give you CO2 plus H2O. Okay. Now for balancing the equation, this is 8 CO2 and 9 water. So if you see the total number of oxygen on this side is 8 is the 16 plus 9. So we have 25 O2. So here we can multiply it with 25 by 2. Okay. So this is the balanced equation. Now you have to just calculate the combustion value. So here in this reaction, we have to take the delta H values of products minus delta H values of reactants. So we have in the product carbon dioxide, water, and in the reactant side it is octane. And for O2 it is 0 because it is a native element. So we can put the values here. 9 times of H2O, that is minus 240, plus we have 8 times of carbon dioxide, that is 490. So this much is the enthalpy of products minus enthalpy of reactants. So the reactant is C8H18, that is your 160. Okay. So if you solve this, the values are in kilojoule, we'll get 6240 kilojoule. Okay. Now the question is asked for 6 millimoles. Okay. So this is for 1 mole. For 6 millimoles, we have to multiply with 6 into 10 to the power of minus 3. So we will get 6240 into 6 into 10 to the power of minus 3. So that will be equal to around minus 37. So here it is minus, here minus 37.4 kilojoule. Okay. So the correct answer for this question is option number B. Here you need not think that why it is not coming negative. Okay. Because heat of combustion has to be always negative. Okay. Now let us see the next question. Equal volumes of methanoic acid and sodium hydroxide are mixed. So if X is the heat of formation of water, then heat evolved on neutralization is. Okay, so when water is H plus and OH minus, okay, this is when both are strong, like strong acid and strong base is mixed, we get X value. Now one of the acid taken is weak, so that is why the value will be less than X. So the correct answer for this question is option number D. Next, which one of the following has delta S is greater than 0? The delta S is positive, we have to calculate. So for first one, if you can see, there is one gaseous reactant, but product is becoming solid. And if you know the entropy order, it is solid, liquid and then gas, right? Since we are getting a solid product here, that is delta S is negative. Now here you can see from aqueous to solid again, right? That is like we can say from liquid to solid. So this is also delta S is negative. Now here we can see from solid to aqueous, right? So delta S is or entropy is increasing. So entropy will be positive in this case. Correct answer will be option number C. Next. The total entropy change for a system and its surrounding increases if the process is irreversible, right? For irreversible process, the entropy always increases. So the correct answer is option number B. Next, delta S is positive for the change. See, whenever randomness will increase, delta S will be positive. So mixing of two gases, randomness increases. Boiling of liquid, that is from liquid state to vapor state, more randomness is increasing. So delta S is positive. Melting of solid, from solid to liquid state, it is going again entropy or randomness is increasing. So delta S is positive. So all the three are correct. So the correct answer for this question is option number D. Next, if delta G for the given reaction is known, one may determine all the following except the. So the question is, if we know delta G, then what all we can calculate? Direction of spontaneous change at the standard conditions. Yes, if delta G is negative, it is spontaneous. If it is positive, it is non-spontaneous. Position of equilibrium at the temperature for which delta G is known. We can know this. Delta G is equal to, we have this formula, minus NF log K, right? Next, usefulness of catalyst in controlling the equation. So there is no relation between catalyst and delta G of a reaction, okay? So this one we cannot tell. So the correct answer for this question is option number C. Maximum amount of useful work that can be produced at a standard condition, that is the definition of delta G. So this one also we can calculate. So the correct answer for this question is option number C. Now see, question number next 21, entropy change of the system and the surrounding in equilibrium. So whenever the system is at equilibrium, delta S is equal to 0 or that is constant. Correct answer for this question is option number C. Next. So delta G values for the reactions are given to you. You have to calculate. Okay, so I'll write this reaction for this one once again. S2 plus O2, okay, will give 2SO2. Delta G value is minus 544. Next we have 2Zn plus S2 gives 2ZnS. Delta G here is minus 293. Next we have 2Zn plus O2, 2ZnO. Delta G for this is minus 480. Okay. Now the question is asked to calculate the delta G for this reaction, that is 2ZnS plus 3O2 give you 2ZnO plus 2SO2. Okay. Now you have to just arrange the given reaction and find out this one. So you see in the required reaction, ZnS is on the left hand side. So which reaction has ZNS? Second reaction is having ZNS, but it is on the right hand side. So we can reverse the second equation. So if I reverse the second equation, I'll get 2ZNS gives 2Zn plus S2, right? And this value will become plus 293. Now, second you see 3O2. So now if we take these two reactions, S2 plus 2O2 will give 2SO2. This is one reaction. And the other one is this one, 2Zn plus O2 will give you 2ZnO, right? So S2 plus 2 delta G is minus 544, and we have 2Zn plus O2 gives 2ZnO, that is we have minus 480. Now just add these two reactions and check whether we are getting the reaction that is asked in the question. So that is this reaction, right? So this is the reaction that is asked in the question. So we will add these two reactions and check whether we are getting or not. So if we add now, you can see 2Zn we can cancel, right? Then we have S2 we can cancel. We are left with 2ZnS, okay, plus 2O2 plus 1O2, that is 3O2. We'll have 2SO3 plus 2ZnO, right? So now if you see, this is the reaction, same reaction that is asked, 2ZnS plus 3O2 plus 2ZnO plus 2O2. So just the value that we are getting is 293 minus 544, and then we have minus 480. So if you solve this, the correct answer for this question will be minus 731. That is your option number A. Okay. So correct answer for this question is option number A. Now let us see the next question. Which of the following does not result in an increase in an entropy? So whenever, as we know, there is randomness is there, solid to liquid to gas. If the phase is changing from solid liquid to gas, solid to liquid, liquid to gas, entropy will be positive. Now crystallization of sugar from sucrose solution, that is from liquid to solid, right? It is going from liquid to solid, so entropy is decreasing. So the question is does not increase, so that means entropy is decreasing. So the correct answer for this question is option number A. Okay. Next. Entropy change involved in the conversion of 1 mole of liquid water at 373 Kelvin to vapor at the same temperature will be. Okay, so this one we have this formula, entropy change formula is delta S is equal to delta H of vaporization by T, right? So if we see here, delta H of vaporization is 2.257 kilojoule per gram, right? And temperature is how much? 373 Kelvin. According to the question, the answer is asked for 1 mole of liquid. So 1 mole we should multiply, that is water. So 18 gram per mole. Okay, so per mole we can now calculate this. The answer for this question you will get 1.09. Okay, 0.109. The correct answer for this question is option number B. Okay, next. Das is an intensive property. So this definition is very important. Intensive property is that property which do not depend on the amount of substance, right? Whether you take 1 cup, 2 cups, the value will be same. So we know temperature is an intensive property. Correct answer is option number A. Next. Das is not a state function. So again, state function are those functions which do not depend on the path followed. They only depend on the initial and final values. So there are only two path functions, that is work and your heat, right? So work energy is a path function. Correct answer is option number B. Next. Delta U by delta T of a system is equal to the, so delta U by delta T, delta U is the heat constant at heat exchange at constant by T. So this is, sorry, we have delta U by delta T. So this value is nothing but your heat capacity at constant volume. Okay, so please remember this one, this is your CV, and delta H by delta T is Cp. Okay, please remember these two equations, very, very important. So that what does that mean? The heat exchange at constant volume. A heat exchange at constant volume is your CV, and the heat exchange at constant pressure is your Cp. Next. Again, the same formula we can use. The difference between delta H by delta T minus delta U by delta T. This is very simple question. Only thing is we should know this equation. So delta H by delta T is Cp. And delta U by delta T is Cv. Just now I told you. So Cp minus Cv is nothing but your R, very famous equation. Correct answer for this question is option number B. Okay, next. When an ideal gas expands isothermally against vacuum, the change in its internal energy is equal to. So what is the formula of delta U? Delta U is equal to Q plus W, right? Now whenever you see it is isothermally, work done will be equal to 0, right? Sorry, whenever it is against the vacuum, work done is equal to 0, because work done formula is minus P external into dV. In vacuum, P external is 0, so work done is equal to 0. Now again, it is given isothermal process, so delta U is always 0 for isothermal process. So the correct answer for this question is option number A. Next, a process is spontaneous at all temperature when? So we have this one, delta G is equal to delta H minus T delta S, right? It will be spontaneous if delta G comes out to be negative. For delta G to be negative, delta H can be negative and this one also should be negative. So this one will come negative if delta S is positive. So my condition should be delta H is negative and delta S is positive. So the correct answer for this question is option number C. Okay, so students, these were the top 30 questions from thermodynamics. So thermodynamics is not an easy chapter, but if you focus on some important formulas like work done and gives free energy conditions, you will be able to do the questions from these topics. Okay, so if you haven't studied this chapter, just go through this video, do some 30 questions, look at the formulas of work done. That will be enough for the exam. If you have found this video useful, please like, share and subscribe our channel for the upcoming videos. Thank you.